Hi, and welcome to the Data Wranglers, a conversation about the latest trends in data engineering, hot takes, and insights on the data industry.
And I'm Joe Hellerstein. I am super excited to introduce this week's guest, Jun Rao. Jun is a co-founder at Confluent, the rocket ship startup behind Apache Kafka, and he's somebody I've known in the data world for years and years. So let's jump right into it. I want to introduce you folks to Jun. He's worked on, of course, open source projects like Kafka, but also Apache Cassandra. And back in his days at IBM Research, he also worked on proprietary systems like IBM's DB2 database. So he goes deep in both open source and the roots of the database industry. He's the co-author of more than 20 reference research papers, the co-inventor of more than a dozen U.S. software patents, and he has a PhD from computer science at Columbia. Jun, thanks so much for joining us.
Yeah, thanks, Joe and Jeff, for inviting me. Yeah, I think sounds like this is going to be a great conversation.
Yeah, welcome, Jun. Thanks for joining us. So, for our listeners who may be newer to the industry, in brief, what does Confluent do?
Yeah. So that's a good question. I think what we do at Confluent is we think we are creating a new category of infrastructure. If you look at the infrastructure space, right, historically, what people have been using are mostly various flavors of databases. What do you call those data at rest systems? So at the gist of it, what's happening is when something interesting in the world happens, those systems' primary responsibility is mostly just for recording that. And the leveraging of that data typically happens later. And a lot of them, it's through batch processes. You have to wait for the user to take action or pay some attention before the data can be leveraged. What we created at Confluent and based on Apache Kafka is a new system we called data in motion. So the difference is in that world, when something interesting happens again, not only will be recording that in the system, which is important for durability and other things, but we will also be triggering the leveraging of the data immediately. So typically applications will predefine what they want to do and act on those new information. And when those new information happens, it just triggers those predefined actions. So we believe, I think, as people are moving towards more digitized and moving towards more real time, we believe it is actually a fundamental different way, but I think more effective way of leveraging the data.
Great. So, as part of that, you mentioned advancing the technology of Apache Kafka and helping users adopt Kafka-based solutions more easily. So, you can give us an overview of what is Kafka?
Yeah, that's a good question. So within Kafka, we believe we have a system that has two main parts. One is the storage system. So as I mentioned earlier, I think we want to make this a data in motion system. So we have to provide a way how we store the data to make that easier. So we have a way that can store the data that's easy for delivering data as a stream so that you can consume those incremental events as they happen. And then, of course, we want to make that more scalable, as a lot of other distributed systems are doing. We want to make that can scale out by adding just new brokers, new hardwares, and then we want to make that durable, highly available, and all those good things. So that's the storage part of the system. It's geared towards keeping the data at scale, but also delivering data incrementally as a stream. The second part is the processing part. Just once you have the data stored as stream, right, it can deliver to the applications as stream feeds. What do those applications do with the data? Well, it turns out, I think a lot of those applications are doing something that has very common pattern. A lot of those are like what people would do in a database world, doing some SQL-like operations like projection, transformation, a little bit data enrichment, aggregation. The kick is, it's not like a one-time query you do. Instead, what you do is, you define this as a continuous processing capability, and as those new interesting information are coming in, it will just trigger those predefined continuous process as soon as possible. So for that, I think we need a processing framework can do those common stuff easier. So that's a second part of Apache Kafka. We have some higher level stream processing library can provide some higher level abstract to allow the applications to specify those common continuous processing more easily.
Thanks, Jin. That's super clear and helpful. What's interesting, I think, about Kafka is that it covers a lot of ground, and in some sense, I know technically it's the descendant of a bunch of older and pretty overlapping enterprise technologies. So, I thought for our listeners, I would just try to play a little game with you of bingo. Just some quick yes/no questions. So I'm only going to give you the opportunity to say yes or no, which might be frustrating, but we'll get into the nuance right afterwards. I promise. Okay. So, can Kafka be my stream processor?
Yes.
Can Kafka be my publish subscribe bus?
Yes.
Can Kafka be my persistent queuing system?
Yes.
Can Kafka be my database?
No.
Okay, interesting. That was super fun. So a lot of yeses, a little bit of hesitation on the last one. You landed on no, but I could hear you wanting to say a little bit of maybe. So
that's right.
Maybe we can start with those things and go through them in terms of use cases you're seeing in the real world. So give me an example of how we use Kafka for what we might think of as stream processing.
Yeah. So as you mentioned earlier, I think the usage of Kafka is pretty broad, and then is actually overlapping with a lot of the traditional use cases and some of the newer use cases. But I think broadly speaking, I would say there are a few of those categories. The first thing is building up microservices, what we call those event-driven microservices. Historically, a lot of applications have been driven or built on those data at rest systems, which means I think a lot of information in those applications are kind of stale, right? So you just have to wait for the user to act on that before you can leverage the gist of the data. With those new event-driven applications, we turn that around, which is, even when the user is not proactively looking or engaging with the application, you actually have the opportunity to leverage the data as they show up. And then you can sort of leverage that and then prepare like a derived view so that it's more convenient for the user to consume when they do engage with the application. So the benefit is now the information those applications get is a lot fresher. And you also have the opportunity to proactively engage with the user even when they're not looking. So that's a pretty broad category, is all those event-driven microservices. I think a second category is there are lots of messaging use case. As you mentioned, there's a traditional messaging persistent queue use cases. And then we are also seeing a lot of use cases where the traditional ETL process, they are being moved into real time. So instead of doing this in batches, once a day, once a week thing, people want to do that continuously. And the Kafka can also be a great fit for those.
Gotcha. Okay, interesting. Yeah, that makes sense to me. And some of these use cases from the past, they're kind of starting to take on new shapes, as you say, with microservices and stuff. When I think about queuing systems back in the old days, you may remember this. There's a conference every couple of years, the High Performance Transaction Systems Conference, and Jim Gray famously ran this conference. And it seemed like back in like the early 90s, every 2 years he would come and either have a paper that said my database is a queue or my queue is a database. And the sort of idea of looking at these things back and forth is really interesting. Is data management about storage, or is data management about getting data to applications, right? And Kafka clearly, from what you're saying, is in the latter category. But I do want to kind of play this dichotomy with you. It often makes people's heads spin. They're like, well, maybe Kafka is a database. You guys have a language called KSQL, right? Maybe tell us more about that. And how I can think of Kafka as a system I can query.
Yeah, that's a good transition. I think just to echo on what you said earlier, I think when I worked at IBM, I used to work with a bunch of like database legends. I think Bruce Lindesay, one of the pioneers in the database world, right? He used to tell me, I think within a database, the real data is the log. Everything else, including the tables, those are all derived, right? So it just, I think in the database world, I think the log is really just an implementation detail. It's not meant for end user to to consume it directly. So what we did in Kafka, just we turned that around. We believe actually, as the world changes, there's a lot of need for different places to need the data. And then the simplest way and the most effective way to propagate those data is actually model the data as a log so that you can keep flowing those data across to all those places. So that's essentially what we did. We abstracted out that commit log concept in the database, but made that really a first-class citizen. So we make that more scalable, right, more concise, and other things to make it more performing. So that eventually led to Kafka. So that's sort of the storage part of it. But as you alluded to the second part, the second thing is, what do you do with those stored data now that they are stored as stream? So that's sort of the KSQL DB, the processing part of it. So when we looked at how people are using those data, initially I think a lot of applications, they really just latched onto our lower level API, which is you can, of course, publish a record into a stream, and then you can read it back, right? And then once you get it back, it's pretty flexible. You can do anything you want. You can make some external calls, you can build some in-memory cache, right? You can do a lot of other things. But as people are building more and more of those applications, what we realize is a lot of the places they actually want to do something that have some very common pattern. Because a lot of places, they just want to take the raw feeds, essentially try to derive a new view of that. And that view, I think, could be materialized. It's just that that new view allows the application to be able to consume that data or look at data in a much more convenient way so that they can get this better insight for the underlying data. So this process typically requires to massage data a little bit, which means sometimes you need to do a little bit projection. You may want to do a little bit filtering, right? You may want to join the stream with a reference table for some enrichment, right? Maybe you only have like a zip code, but you don't have any information about the geographic location. But a reference database could have that, right? Joining those two pieces of information together will give you this more information in the stream that you can leverage more information on top of that. And they may also want to do some aggregates, right? Potentially over some windows. So so that's the first part. You want to do a lot of like transformation of that. And then once the information is available, I think you also have some state, right? Maybe you have pre-built some state for a particular window aggregation, and a lot of the applications from a user interactive perspective, often they want to check the current state of that materialized view you have been building, because they may want to compare this hour's aggregate data with the previous hour, right? With all those interesting applications that you can build. So you have these two parts, which one is this continuous transformation to derive a new materialized view. And the second thing, once you have the view, a lot of applications want to serve that view back to the application. So that's what the KSQL DB is about. I think that's why I think the name has the DB in it, because I think at one hand, it has this processing engine that allow people to define those real-time continuous processing using a SQL-like language over those streams. A lot of those are coming from Kafka. And then this allows you to essentially build this materialized view of that. But in the second phase of Kafka, we just realized, okay, now that we have that view, a lot of people actually want to access that. We could just, export that view into some external database, right? But someone has to manage that database. But since we are maintaining that view already, we thought maybe we can just open up the API so that people can query the state of that view as they see fit. So that's the second piece of KSQL DB. So we also have a API for like a regular point SQL query, so they can check the value of the state as they are being materialized.
Okay, got it. That's really interesting. There's a bunch of things you had there that I think really resonated for me. The first is, you talked about just sort of like transformation of data and queries being the same thing. And I think that's something maybe that people don't generally realize, but it's becoming quite a trend, I think, right now, that data transformation and data querying, so using SQL, for instance, for transformation, or variations of SQL like KSQL, Makes so much sense because the things you're doing are natural to the query languages that already exist. Another thing you said that I think was really intriguing. I want to get back to it and put a point on is you talked about streams and window queries. You also talked about point queries, and maybe help me think or help our listeners think about the difference between walking up to a database and asking a query and a subscription to a streaming query.
Yeah, I think there's this sort of subtle difference between like a stream and like a table, right? So we view this, it has some duality. Just if you look at like a database table, right, that's updatable, what it is, right? Under the cover, it's like uh, a sequence of changes, right, that you made to the state. And in the end, it's just a table view give you the current state of that. But you can also flip on it. You can just say, okay, what I really want is really just all the individual changes, right? And then there are applications where you may prefer to treat those changes as just pure additions, or you want to view those as like updates to the table. So I think what we provide at the KSQL is, just we give you this concept so that you can reason about, okay, when you have a list of changes, right? Do you want to view that as sort of independent, just additions, or do you want to treat it as like a database table thing where updates are possible? And then, of course, the semantic of dealing with that would be different, right? When you talk about things applying a max, applying a sum, right? I think treating those differently, I think will give you different answers. So we'll give you this concept. So that makes we think makes the reasoning of the stream a little bit easier. Now about the point query, I think it's really just there. This is a bit orthogonal, but it's also sort of interdependent. So the continuous part, when people are reasoning about streams, allows people to essentially derive a new data set in an incremental way. So that sort of takes the original data and transform in some ways and give you like a new view of that. So that's what a lot of the stream processing has been doing. But the next question is, once you have those views defined, what do you do with those data? So when we look at a lot of those event-driven applications, what we just realized in the end, right? For a lot of the applications right now, I think it's still convenient for them to have this state view of the data. Is what's the current state of the view that I just derived, and then be able to interact with those. So that's the value of the more traditional SQL. So you can have that view exposed through like a traditional SQL API. Then people can essentially query the state as they are being virtualized. Then the benefit is, you just in a single application, right? You can combine that stream transformation and the state query in the same infrastructure.
Mm-hmm. Yeah, it's that duality is really cool. I think it might be complicated for some folks, right, to think about which of those modalities they're thinking about. Are they thinking about a changing database, or are they thinking about a stream of updates? Right. It's you got to get your head around both of those.
That's right. That's right. Yeah. That's why we hope, with some of the higher level abstract, we can make that understanding a little bit easier.
Yeah.
Yeah, and I really appreciate the flexibility that can provide, but it also leaves me wondering, what is Kafka a bad fit for? Do you have an example of a Kafka deployment anti-pattern?
Yeah, that's also a good question. I think that's sort of the trend that we saw a little bit as well. Just once something is getting popular, everybody, who haven't used it will think, oh, I gotta have some way to use it, right? Okay, what I'm doing now, can I fit that into whatever that infrastructure is? I think Kafka is a little bit like that now. I think some of the obvious anti-pattern is, okay, so Kafka is really good for streaming, right? Streaming the data. But we're not really good at like just random lookup. If your job, is to have some data and do some random lookup with some key, right? There are lots of other key value stores out there can do this job much more effective on Kafka. You can sort of do that in Kafka, but it's not necessarily the strength of Kafka. You may not get a true benefit of Kafka. So that's sort of just an example.
Yeah. So in your experience, how real time do people need their query outputs to be? For example, I've heard others advocate for micro batching over like pure continuous streaming. So maybe better put, then, what application scenarios really need this aggressive real time data?
Yeah, that's an excellent question. So if you look at what we do at Kafka, right? Okay, we are not building this for high frequency trading, where you care about sub-millisecond latency. That's not our sweet spot. There are specialized applications can do this sort of better, right? And they have been doing that much longer than Kafka does. But for anything, I think that's millisecond above, and then maybe up to a few seconds. That's what we saw where the sweet spots are. I think a lot of those latency are really still human observable latency. I think we're talking about maybe just a couple of seconds, right? So when you ride a Uber or Lyft, that's the experience you will get, right? When you get some online delivery, right? That's sort of the experience you will get. So that's the spot we are targeting, a few seconds. But if you look inside the infrastructure, it's getting interesting because I think to build that application, if you look at how a typical sort of online application is built, under the cover, they may have lots of steps because some stuff I mentioned, right? They may need to do some transformation in real time to clean the data a little bit, to standardize a little bit, right? I think some of them are pretty sophisticated. It's not just like one transformation that will be doing that, right? The easy thing for them, to break that into different stages and then attack each stage with the right tool and with the right framework. So, and each of them together, right, may take a little bit of time. But I think to build a final user experience, you have to accommodate for the whole process, right? That could add up. So that's why I think the more you can provide at a little bit like lower latency through those more modern event streaming systems, the more you're giving the upper level application more opportunity to build more sophisticated logic on top of that to provide that low latency user experience. Yeah, because some of the applications at LinkedIn, I think they can take maybe 20 or 30 steps, right? And each of them essentially is like a micro service that does some of the stream processing capability.
So I want to drill down on that. That's really interesting because what we're talking about, and you've been saying this since the beginning, is kind of how Kafka can let data or changes to data drive these external listeners to take action pretty much right away. So, this kind of leads me to a question about orchestrating processing more generally. I think sometimes we think about the way you orchestrate processes through workflow tools, but is Kafka and kind of this data-driven, event-driven world an alternative to a workflow system like Airflow? Or do your customers tend to use sort of workflow systems to control or orchestrate processing and Kafka to move data around?
Yeah, I think we have been seeing a bit both. I think Kafka is certainly great at moving data around. And then there are lots of use cases in the world, especially as people are moving toward the clouds, because as people are moving to a different environment, the primary thing is you need to be able to get data there, right? So now Kafka is really great at that. You can move the data from your on-prem data center to the cloud. You can move that across cloud. You have multi-cloud strategies. And in terms of workflow, I think a lot of the microservices people have been building essentially are various workflows. I think a lot of those are like asynchronous workflow. A lot of things, when a user takes an action, right? There are a lot of things you could do, but they don't need to be part of that response to the immediate user actions. But you can do that on the side and then do it as quickly as you can, right? So that is what Kafka is really good at. It's not good at those sort of request response style things, right? So that's I think what a lot of databases are doing. But if you have some things that you need to leverage data through a bunch of steps, some workflow, Kafka is great at that. You can build microservices on top of that. And then that allows you to take that new piece of information and act on that as quickly as possible without blocking your immediate user request responses. And in terms of the tooling, I think there are a lot of framework, right, that can do workflow management. I think what Kafka offers is, okay, we offer this kind of process at different levels. We have this lowest level API where we can just give you the raw data that you want. So this gives you a lot of flexibility in terms of the tooling they are using. You can bind that to different programming languages, right? There's a lot of things once you have access to the data at a lower level. On top of that, I think people can build various tools on top of that to make some of the common processing a little bit easier. I think we build a little bit like Kafka Stream, KSQLDB to make certain processing much easier. But I think some of the people may be familiar with some of the existing framework like workflow management. I think some of them, I think people could build tools to adapt some of those onto some of the infrastructure we have as well.
Yeah, I think one of the really cool things about microservices in the cloud, right, is that what we used to think of as control flow, so a function calling another function, is now pretty much data movement, right? When one microservice is invoking another, it's sending a message, right? And that message is data. And if you want that message to be reliable, it ends up becoming data that might be managed in a system like Kafka. So I think it's really cool how, as data geeks, right, how more and more of what we used to think of as control flow actually turns into data flow.
That's true. I think a lot of those things are, emerging. I think a lot of those, I think if you can access the data, I think directly, right? I think then you can potentially just have like a single framework that can do both control and the data using the same framework.
Very
I
cool.
wanted to zoom out a bit from this. So, noting that Confluent is one of the notable success stories in going from open source to a very successful commercial company. And so I wanted to get your take on that. Like, do you think this is the way enterprise software companies will succeed in the future? Or is Confluent and Kafka in some way special?
Yeah, that's a good question. I don't know the full answer to that, but I can just give you my perspective. I think in terms of open sourcing or not, I think what helped a lot for Kafka, especially in the early days, is I think open sourcing, especially through Apache Foundation, helped a lot in terms of sort of building the user space for us. I think a lot of the enterprises, over time they had good experience for projects coming from Apache Foundation. So they sort of have trust of this Apache brand. So when we open source Kafka, right, to Apache Foundation, I think what we realize is a lot of the enterprises, not just the tech companies, because they always are the early adopters, right, of all new technologies coming out. But a lot of enterprises, you will see, these are telecoms, retailers, they actually start adopting that in the early stage. So I think that branding name certainly helps. And the second thing is just, I think it helped quite a bit in terms of just consolidating the community. Earlier, when it was just like a GitHub project, right? I think that there are quite a few of those Kafka clones where people want to just tweak that and improve in some way, and then they felt it's easier and then quicker for them to do themselves rather than contributing back. But once Kafka became an Apache project, I think people felt that's actually the place where it will stay. It can stay for a long time. I think because it's not controlled by a single company. And then people started, just contributing all the things that they wanted, right, over time, I think, to Kafka. So, and then people started just orienting themselves around this platform. I think that sort of helped consolidating all those efforts, right, into like a single platform that eventually also helped a lot in terms of growth of this technology.
So how does cloud hosting of open source like Kafka play into Confluent's market? So why use Confluent Kafka and say not a cloud vendor's packaging of the open source Kafka?
Yeah, that's a good question. I think we started Confluent with like a on-prem model because that's was the mainstream way of consuming the software around that time. But starting from 4 years ago, we started building our SaaS offering. So the reason we are doing that is we truly believe that's actually the better way of delivering the software. Because uh, as most people who have used Kafka know, it's a distributed system, right? It's actually takes some time to get used to it, and in terms of the day-to-day operation. So by offering that as a hosted service in the cloud, we're actually taking over as the operational team for our users, and then this allows our users to focus just on their core business, right? Which is probably more value add for them. So that's why we feel there's a lot of adoption in various SaaS services, and we want to make sure our service is competitive for this technology. Now, since Kafka is open source technology, we could offer that as a SaaS service, but other vendors can offer that as a SaaS service too. In particular, Amazon has been offering a similar service called MSK. Now, how do we differentiate from those services? Well, I think to put it simply, I think we just try to differentiate in 3 different ways. The first thing is cloud native, because we believe to really build a good SaaS service, right? You have to sort of take the software you have and then may potentially even re-architect that a little bit so that it can leverage the cloud resources more effectively. Because the cloud world is a little bit different from the on-prem world. In the on-prem world, you buy the hardware, you pay a upfront cost, right? And you can sort of use it for free forever. But in the cloud, it's different because the resources you use, right? Typically, you pay based on what you use. So, and then there are also lots of different type of cloud resources. They have different trade-off in terms of performance and cost. So by building your system to be more cloud native, you can actually take advantage a lot of those different types of cloud resources, and as a result, build a service that's much more efficient, that's more appealing to the end user. I think that's sort of the number one thing that I think we can build by being the team has been in this space for the longest. I think we understand the architecture a lot, and then we can sort of evolve our architecture to make that more cloud native. So that's the first thing we think we can build a differentiating service. The second thing is completeness, because I think for a lot of data systems, right, and Kafka in particular, to be successful, you have to make sure it integrates with the rest of the data ecosystem. Because today, I think a lot of data are still locked into various legacy systems, various databases, various files, and maybe a lot of traditional messaging systems. And then to really leverage this data in motion platform, you need to get all the data integrated into Kafka. Right? So, and then similarly, once data is in Kafka, there are a lot of destinations people want the data to be flown into, right? A lot of places, of course, they want to build those event-driven applications, but there are a lot of places they just, we have a data sink and that needs data, so the data need to be flow into that systems. This can be Elasticsearch, this can be S3, this can be a lot of data lake, data warehouse systems. So to really have your system work well, right, you need to be able to integrate with all those data sources and data sinks. So that's the second thing we have at Confluent over time. We, on top of the framework we have in Apache Kafka, we build 100 plus of those different connectors that can integrate Kafka with those common data sources and data sinks. So that makes the usage of the whole data ecosystem a lot easier. The last part we have is really just completeness, because of what we have seen in the world is, I think as companies are moving towards the cloud, I think they want to have this portability of their software stack, because as the environment changes, right? Today, maybe they want to run their stack on-prem. Tomorrow, they may want to run the same stack on AWS. But another day, when they make acquisition, right, or other things, they may want to run the same thing in GCP. And a third day, maybe they Azure has like a new tool for machine learning that's appealing. People may want to start leveraging those. So for all those, I think people want the data and then the software stack on top of that to be more portable so that they can have this agility to move it to the environment where they really want. So that's a third other thing we have at Confluent Cloud, which is we offer our SaaS service not only just in one cloud, we offer that in all the three major public cloud, AWS, GCP, and Azure. And we also have the same software stack available as a Kubernetes operator. So if you want to run it in your own private cloud environment, you have the ability to do that as well. So I think with all those three things, cloud native, more completeness, and then being everywhere, we hope we can build a truly differentiating service because we are truly focusing in this particular area.
Gotcha. Yeah, that's pretty comprehensive. Listen, Jun, you guys are deployed all over the place. I can't turn around without running into Kafka. So maybe you could pick out one of your favorite sort of true data stories, a particular data wrangling challenge that stands out to you as particularly interesting or memorable.
Yeah, I think there are lots of those. I think one of the things I think I would say I think probably just in some of the ride sharing companies. I think they are pretty heavy of Kafka user, and if you look at what they are doing, right? Of course, internally they are using a lot of machine learning and AI to build various models so that they can predict certain things, right, a lot better. But at the core of that is they need various kinds of feature extraction to really build that model, because the input data may be a little bit noisy, right? And it's also not standardized. If you just apply it, use it as it is, it's sort of garbage in and garbage out, right? So you sort of have to massage that a little bit, cleaning it a little bit, standardizing it, do the right feature extraction so that you can start building those models. And then once the model is built, I think, of course, you want to be able to leverage, apply it online. So that's the trend we are seeing. I think a lot of those, the application of the model and the checking of the model is moving towards in real time. It's just as new events are coming in, they want to apply the information on the model that they pre-built and to see, okay, what they can get out of this new information. And as part of this process, the same thing needs to happen, which means they need to clean the data, they need to standardize data as those new data are coming in so that they can do the right feature extraction and then apply an unchecked model. So that part is what Kafka is really strong and good at it, because we are providing this not only this real-time feed of data in continuously, but we are also offering the real-time continuous processing so that people can do this kind of cleaning, standardization, feature extraction using some of the more convenient tool in real time, and then apply that to whatever AI machine learning capability they have. I think this is actually pretty cool usage of the event streaming and other technologies together.
Music to my ears. So thank you so much for joining us today, Jun. So our guest this week was Jun Rao, co-founder of Confluent. And we'll wrap up there. If you have a question or topic you'd like us to tackle, reach out to us at datawranglers@trifacta.com.
And as always, make sure to review and subscribe to the Data Wranglers wherever you find your podcasts. The Data Wranglers podcast is brought to you by Trifacta, the data engineering cloud. On behalf of Jeff Heer and the whole team, thanks for listening. I'm Joe Hellerstein. See you next time.
Thanks, Jeff and Joe.